Alright guys, let's hope third time is the charm making this video for you guys. So we're going to dive into solving differential equations using slope fields. Before, when we were separating variables to solve the differential equations, that was more of an algebraic approach. This is going to be more of a visual approach to solving the differential equations. So in order to do this, we have to first graph a slope field. So to create the slope field for a differential equation, we're going to substitute x and y coordinates of the ordered pairs into the differential equation. The thing we have to keep in mind is that a differential equation tells us about the derivative of a function, which means it's telling us about the slope of the tangent line at that point. So once we have the slope of the tangent line, we're actually going to graph a tiny piece of a line that has the slope that we calculated. And as we do the example, it'll kind of make sense as to what that means. So we've got this differential equation, dy over dx equals x over y. So in order to do this, we're going to sketch a graph of the slope field at the points indicated. So to help you kind of organize your work, you do not have to do this, but to help you organize it, it might be useful to make a table. So for your x and y coordinates, and then we're going to put the slope at that point in the table as well. So this is our differential equation. The numbers that we're going to put in this column here come from this equation, from plugging in our coordinates there. So the point -2, 2, if I plug that into this differential equation, I would get a slope of -1. -2, 1 would give me a slope of -2. -2, -1 would give me a slope of +2, and then -2, -2 would give me a slope of +1. So all I did is take these 4 points here and plug them into the differential equation to get the slopes at those 4 points. So what that would mean, I'm going to go ahead and draw these 4 on the graph right away. So the point -2, 2 has a slope of -1. So I'm just going to go ahead and pretend that I'm drawing a line through it that has a slope of -1. Then the point -2, 1 has a slope of -2. So it needs to go through this point and have a steeper slope than that one. So if it helps to kind of visualize, I sometimes in my head go, a slope of -2 means down 2 and right 1. So it almost means that I would need to connect it to this point, and I kind of sketch it that way. Then let's see, -2, -1 would have a slope of +2, so I need to go up to that point, so maybe here. And then -2, -2 has a slope of +1, so I'm going straight up there. There we go. Then we can kind of do the same thing moving on with our other points. So -1, 2 would have a slope of -1/2. -1, 1 would have a slope of -1. -1, -1 would give us +1. And -1, -2 would give us a slope of 1/2. So now I can take these 4 slopes and graph them on here. So -1 over 2, so down 1, right 2. I need to connect it over to here, so maybe something like this. It's not as steep as -1. So then -1, so it's going to be the same slope as this one. Then a +1, so maybe something like this. And then a +1/2, so maybe something a little bit more like that. It doesn't need to be exact. We just need to look at, is it positive, negative, and should it be steeper or not than the one before it, right? So the higher the slope, the steeper it is. That's all we're really looking at here. All right, so then if we were to keep going, again, you don't have to make the table, but it's kind of helpful to just organize your thoughts. So the point 2 would have a slope of 0. The point 1 would have a slope of 0. So those two are nice and easy to graph because those are just horizontal tangents. So then we've got the point 2, which would give us a slope of 1/2. We've got 1, which would give us a slope of 1. 1, which would give us a slope of -1. And 1, -2, which would give us a slope of -1/2. So again, just go ahead and put those on there now. So down, what do I want? +1/2. So maybe something like this. Then a +1, so maybe like that. then a -1, and a -1/2. So kind of like that. And then we've got these points to do. I'm not going to make the table, but we can kind of talk through it. So the point 2, would give us a slope of +1. Then we would have a slope of +2, so we're going to be a little bit steeper. Then we're going to have -2 and -1. Yeah, there we go. That's right. Okay, so again, it doesn't need to be exact, you guys. Don't freak out about what it looks like exactly, as long as you've got the right idea going on with your slopes in terms of positive, negative, and steepness. And then we're going to use that to actually sketch a graph now. So sketch the graph of the solution that goes through the point 0, 1. So in order to do this, the first thing we're going to do is put a point on 0, 1. Now we need to find a solution that is going to match this slope field. So all we're going to do is kind of follow what's going on here. With this being a slope of 0, this tells me that this is going to be a minimum on here, because this side is going to increase and this side is going to, or well, it's going to go up. Sorry, not increase. That's a bad choice of words. But we can see that from here we're going to need to draw the curve going up and draw the curve going up, which tells us this point here right in the middle that we're using is kind of the minimum of it. Don't overthink it, just kind of follow what's going on in your slope field. Let's look at another one here. So this one down here is asking us to estimate the solution to the differential equation and kind of talk about what we know about the original function. So we can visualize what's going on. We can use a slope field to determine the solution by visualizing the shape of the original graph. So what can you tell about the solution to the differential equation using this slope field? Well, I can tell that everything here along the y-axis has a slope of 0. And on either side of it, it looks like the function would be going up towards infinity. So for example, I could say I have a solution right here that looks like this. Or I could maybe have one that starts down here and goes up like this. Or I could even have one that's much farther down here. But either way, when I look at all of those, and regardless of where I choose to start, all three of those look like a parabola, right? They look like this U-shaped graph. So what that tells me is that the original function would have been a quadratic. So if they had given me like a list of options here, I know that I'm going to be looking for something that's got x squared, because that's going to tell me it's a quadratic function. All right. So let's look at these last examples here. So I gave you 4 different slope fields and 4 different equations. You need to match the slope field to the possible particular solution. So if we take a look at those slope fields first, we can see that A and C are both kind of wavy, right? We started out, we went up, we went back down. This is definitely a wavy function going on. Same thing here. This one started up high, went down low, and started kind of bouncing. So we could tell those two are kind of related to each other. You should also right away be able to tell that there's some type of trig function, because it's that bouncing back and forth pattern. Then if we look at choice B, we can see that this is kind of going up, right? Something like this. We don't know exactly what's happening, but we can see it's kind of looking like that. And then option D, we can see is similar to this, but almost the opposite. It almost started up high and is coming down low like this. So let's think about what these equations are that we have. We have cosine, we have e to the x, we have e to the negative x, and we have negative cosine of x. Well, if we think about what a cosine function looks like, we know that cosine starts up high, goes down low, and comes back up. So if we think about what the slope field for that would look like, at the y-axis, we would have a slope of 0. Then we would have negative slopes until it hit 0 again. then we would have positive slopes until it hit 0 again. So we need to look at these graphs and decide which one matches this. Well, A and C are both the ones that we decided looked like trig functions. And if we think about it, on option C, if I start at 1, then it gives me a negative slope till it gets to 0 again. Then it has a positive slope until it gets to 0 again, and then has a negative slope. So this looks like our cosine function right here. We can see that that's exactly what it's doing. So that means this is option C. Now the difference we said between C and A was a very small one, but in option A, we started down low instead of up high. So we started down low and had a positive slope until it got to 0. Then we had a negative slope to 0 again, and then a positive slope. So it looks a lot like our cosine function, but since it started down low, it's our negative cosine. Then we've got e to the x and e to the negative x. Well, hopefully you remember that e to the x is an exponential function. It should look like this, right? E to the x is really like saying 3 to the x. Well, that looks like option B. And then option D down here, we said was the opposite of this. That's because this is e to the negative x. So there's our option D. So you have to know what some of these graphs look like. You have to know the basic parent functions to then be able to match these to the slope fields that we were given. All right, we are going to work through some practice in class. If you've got any questions, please make sure you wrote them down, and I'll answer them when I see you later. Thanks so much for watching.